Hello coders, let's check out power of 231 Leetcode today. It's one of those really low hanging fruits that are good to do once in a while to keep to be in the loop of coding in the group, in this groovy loop of coding, and be on the track for your interview path. So we'll take a look at this one. This is a very easy one. The problem is given an integer, write a function to determine if it is a power of 2, and then he gives examples, which is example 1 is 1, and he says that's true. Your function should return true because 2 raised to the power 0. So 1 is a power of 2 and the power itself is 0 in this case. So the 16 is a power of 2 and the power itself is 4, and 218 is false even though it's an even number. So how do we solve this problem? So the problem can be solved either in C or Python, but we would choose C because we love C for these bit manipulation and those kind of things. So first of all, let us try to look at some powers of 2 here just to give an example. So 1 can be written as 2 raised to the power 0. And 2 can be written as, of course, 2 is raised to the power 2 raised to the power 1. And 4, as you can see, is 2 raised to the power 2. So, and now let's keep going, and let's say 32 is 2 raised to the power 5. So now these are the powers of 2. If you take another one, 256 is 2 raised to the power 8. And what do you see? If you take the binary representation of these, you would see that it has only one bit, the rightmost bit that is set. This one is 10, sorry, and this one is 100, and this one is 10. So that's 4, this is 8, this is 16, and this is 32. Because 16 would be, so if you start with FFFF, this is 15 unsigned, and to go to 16 you will have 1 followed by 4 zeros, and 32 would be 1 followed by 1 extra 0. So there we have it. And if you take 256, you would have 1 followed by 7 zeros, actually 8 zeros, 3 4 5 6 7 8. So there you have it. And what are the patterns, interesting pattern that you see here? One pattern that you see is that all the powers of 2 have only one bit set and no other bit set. And then one more thing you would see is that if you want to multiply number by 2, all you need to do is left shift it by one place, and it basically doubles. So those are the properties we would try to see. And if you see here that how can we say that if this number is a power of 2? So let's try some bitwise operations. So if you had, for example, so if you would see that n and n minus 1, for a power of 2, n and n minus 1 will be equal to 0. And if you want to see why that is the case, let us just take something like n equal to 8. So 8 would be 2 raised to the power 3, and that is 1,000, and 7, n minus 1 in this case, would be 7, and 7 would be, that is 7. So if you see, if you end these two numbers here, what you would see? You would see that this will be basically 0, right? So that is the idea. Any power of 2 would have this property. This should have this property. N minus 1 should be equal to 0. So let's comment out all this code. I don't want you to, and we'll use the beautiful C syntax where you just something like if 0 and if, it basically comments out the whole code and it won't even be compiled. So you don't, we could have also like commented this out, but I just want you guys to use this another trick, if 0 and f and if. So if that is the case, then maybe how about this, we can return if n minus 1 equal to 0, right? Or using the more C kind of syntax, if we can just say if not n minus 1, that means this function returns true, and we say return true, meaning it is a power of 2. Otherwise we say it's return false. And let's see, let's try to run this code. So it has worked for your input 1. If you change, give us some more test cases, like maybe let us give it 1024, and that works as well. So now if we try to submit, let's see what happens. A wrong answer. It's saying we input was 0 and we basically return here true, but the output should have been false. So we need a check also. We're saying if not n, we can just simply return false, and that should take care of that. So let's see. Okay, so that has led us to another failure, which is he has tried to give a number like this, which is, by the way, if your eyes can spot, is basically int min. This is the minimum 32-bit. This is the value of a integer, signed integer. This is the minimum value of a signed integer, or you could say the value that the least that a signed integer can hold. So when that happen, if you give a input to at that level of extreme input, what would happen is we would do n minus 1, and n minus 1 would basically pretty much overflow. So we'll have a signed integer overflow, and this is not a very good strategy. So what we can do is we probably need one more check, that if n is equal to int min, this is by the way the value that he has over there. So if then also we return false, and let's keep running our old code. That is working. Let's do a submit. All right, so that has succeeded as well. So this is there you have it, the power of 2, which has some interesting gotchas, I would say, but it's not that hard. I mean, as long as you know that the powers of 2 are represented in binary. What are the binary representations of the powers of 2? And then when you know that, you would be able to spot the pattern, which is n minus 1 is equal to, should be equal to 0 for a power of 2. Now, uh, before I leave you guys here, I wanted to probably have some more interesting thoughts, which is, for example, there is a function known as, many of these interviews for the operating systems, device drivers, embedded systems, those kind of jobs, they require you to have very low level knowledge, and definitely C is one of the languages that is highly desirable in that area. So if that is the case, one of the very popular interview questions is count set bits. So if you see, before I leave you guys, let's just do a little fast quick implementation of count set bits using this property that n minus 1 clears the leftmost or the rightmost 1 bit in n. So if that is the, let's do a, so int count set bits, so that would be our function name, and the power that is passed is here. Let's say the number that is passed is some unsigned, because we don't want to again have this problem here. So unsigned int n, let's just say that. And so how do we count the bits? So we say int, we have accumulator count bits, and then say while n we would as long as n is non-zero, we would say if, so we'll, first thing we'll do is definitely, if we are going inside this loop n is non-zero, so that means at least one bit is set. So cnt plus plus, and we say n equal to n minus 1, so n equal to n and n minus 1, so basically like this. But we use beautiful C notation here if you want to impress your interviewer, saying that, hey, look, I know that you're looking for something specific in my coding style. So if that is the case, then you just say equal to like this. And that pretty much is your int count set bits function in C, which is very popular, I would say, especially if you're going for a junior position or something. This is one of the very popular interview questions for embedded systems. So before I move, I would like to move this within if 0, because we are not compiling that function. So all that is code is just for our own purpose. And he's complaining here that what is this in function control reaches end of non-void function. I see. So we have not done a return on CNT, which is good that we actually tried to compile it as it is, because I don't want you guys to have some wrong implementation. So let's do this again here and get rid of the old one. And there you have it. If you want to practice some counting set bits once in a while, if you're getting bored, this would definitely get your creative coding juices flowing. And with that, I will leave you guys, and I will see you in the new video. Until then, goodbye.